And there's a question here that I kind of mentioned a little bit on Monday, and that was, what is an average? We use that term very loosely, actually, I should say, we use that term a little more specifically than we should. When we talk about an average, typically what we mean to say is an arithmetic mean. Okay? That's the concept we're talking about. But when we're talking about an average mathematically, really what we're talking about is a measure of central tendency. Okay? A measure of central tendency. You know, where is our data centered? Now, you might say, okay, well, what's the difference? Doesn't the arithmetic mean give us that? Well, it does, but the real difference is, how are we defining the center? Okay, how do we define center? And we're going to look at 3 different ways of defining the center, and that's how we get our 3 common statistical calculations, the mean, median, and mode. Okay, so we're going to run through some of this rather quickly, just because some of this obviously will be review for you, but we want to build into using some of the notation that we've worked with already, the sigma notation, and just having a good understanding of this as well. So, moving a little slow here. The mode. The mode is the most frequently occurring value in a set of discrete data. Okay, remember, let's remind ourselves, what does discrete mean?
Integers, not continuous.
Okay, generally they're integers, they're things that can be counted, okay? They're exact measurements. It is possible to have more than one mode. We could call it a bimodal set of data. And that's when the thing that occurs the most is actually 2 separate things. So if we look down at this data at the bottom, we start by looking at things that are repeated, okay? 18 is repeated, 21 is repeated, 22 is repeated, 24 is repeated, 25, 26, but then here, 27 occurs 3 times. That's going to be our mode, okay? That's going to be our mode. Now, that's for discrete data. For continuous data, you're going to divide it into classes like we saw on the homework. You know, we have it divided into classes there, or here with our heights, we have it divided into classes, and for that, you can look at the modal class, M-O-D-A-L, modal class. Let me just take a snapshot of that. Okay. Cut that and put it over in here. So in this example, the modal class would be the range that the most individuals or the most scores fall into. So this 185 to 190 range, okay? That would be the modal class. All right, so that's one way of defining a center. We're defining the center in this case based on what the majority, or I shouldn't say majority, what most items center at, okay? or what the most items fall on. Our second way, let me do this in a different order. The median. The median is a middle score, okay? The middle score, and here we would order them from smallest to largest. The middle one would be our median, okay? So, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
19.
11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, we have 19. So the middle one would be the 10th item. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 23 is our median. Yeah, our median. This one's easy to remember if you think, when you drive down the road, the median is that part that goes in the middle of the two lanes. On the freeway you have that concrete median between northbound and southbound or whatever. It's in the middle. If we have an even number of scores, then, for instance, if there was another one like 28 on this end, then there would be kind of two middle ones, and we would just find the mean of them. So if there was a 28 on the end of here, we would find the mean of 23 and 24, so our median would be 23 and a half. Okay? So there's our median. And then the one that's used most often, the arithmetic mean. Okay? You may remember in geometry learning about a geometric mean. You guys remember that, kinda? A over x equals x over b. X is the geometric mean between A and B, and you related it to like a right triangle. If you had a right triangle and you dropped an altitude down, then the altitude was the geometric mean of the two parts of the hypotenuse. It's been a while since geometry, right? Okay. Anyways, that's a geometric mean. This is an arithmetic mean. Okay? And here, though, I would like you to make sure that you pay close attention to the notation.
Excuse the interruption. All students attending the John Pennekamp field trip, please report to the school bus outside the athletic center now. Thank you.
All right. So take a look at the notation here. Let's see if I can. There we go, that fixed it. Okay. Some common notation here. N is commonly used for the number of items or the number of data values in a sample or a population. Okay? And this is something that you really need to pay attention to, especially if you're going to be talking about any kind of a mean in your IA. Alright? Make sure you use proper notation. If you're dealing with a sample of data, you would use X bar for the mean. That's how you read it, X bar. Okay? If you're looking at the entire population, you're going to use this symbol, which is the Greek letter mu. Okay? Looks like that. Okay? It's a lowercase mu in case you've seen the capital one. Capital one looks like a capital M. But it's a lowercase mu used for mean of a population. Okay? In general, in statistics, the way to keep them straight is we use Greek letters for population. We use regular English letters for samples. Okay? So when we get to looking at standard deviation and variance, okay, we use S's for samples, we'll use sigmas for populations. Okay, we'll get to that
When we did this in bio, no one knew what the bar, the weird U thing meant. So
Oh.
it's all coming.
Yeah, that's a Greek letter mu, so. So, when you're finding these, they're found the same way. The formula is the same. Now, that's not always true. For variance and standard deviation, the formulas are slightly different, okay? For sample versus population. But here with the mean, it's found the same way. You simply add up all the scores and divide by how many there are. Okay, that's something you learned back in elementary school. However, notice the notation here with our sigma notation. X sub I is the ith data value, and from the first data value to whichever the last one is, we're going to add those up and then divide by n, which was the total number of data values. Okay? So if we're finding the average here, or I'm sorry, the mean here, we would add up all those numbers and then divide by 19. Okay? You know, so if we added those all up, we'd get some number and then divide by 19. You guys know how to do that, so we're not going to waste the time doing it. Okay? So, this brings the question, you know, why defining center 3 different ways? You know, why do we need a mode versus a median versus an arithmetic mean? You know, obviously the mean we use so often, we see the value in that, but when might the median or mode be useful? What do you think?
It's just another way to analyze data. For example, if we go back to that set of data that we had, the mode was actually the highest number in the set, which would actually increase the arithmetic mean. So if you were only paying attention to the arithmetic mean, you would realize that the highest number is in fact the most common one. So by looking at things like the mode and the median as well, you can analyze data on a deeper level and learn more about where the set comes from.
Okay. And really, if you remember, we had looked at, what was it? Yeah, here. We had looked at distribution a little bit, or we mentioned distribution. Positively skewed versus negatively skewed. Okay. Let me actually bring this over here and we'll examine this a little bit more. But this curve here shows really the frequency of scores. Most of the scores here are right in the middle. If there is a symmetrical distribution, your mean will be your mode. And it'll also be, or it'll at least be really close to your median. Okay, it's possible that it could be a little bit off, but they're all going to be pretty close together. Okay. However, if you have a mode down here, but your mean is up here, this is why, you know, the positive and negative is kind of backwards of what you might think. The mean actually for this data would be up here, even though our mode is down here. And that can indicate that we have some pretty extreme outliers on the top end. Okay? Or maybe not that many outliers, but or maybe not that extreme of an outlier, but there are a number of scores up here, even though the vast majority are way down here. Okay? So when we're looking at you know, data that's skewed, this would be our mode. Okay? But you know, our mean might be here. Okay? And again, if it's negatively skewed, we had the majority of people up here, and our mode was up here, but because we had some really low scores, it skewed our data down so that our mean was maybe right here. Okay? So the positive or negatively skewed part is referring to where the mean is in relation to the mode. Okay? So you're right, Zach. It's a way to analyze our data a little bit deeper and get a little bit different of a comparison here. And when you see something that's positively skewed or negatively skewed, you can see that, oh, you know what, our our data has some, for one reason or another, it has some kind of different extreme scores. Okay. Yeah. Zach?
For example, if let's say you're given just one, like let's just say the mean, it would be pretty hard to recreate a data set that would be based off of, like if they just gave you the mean and said recreate the data set that this was drawn from. But if they gave you all three, the mode, the median, and the arithmetic mean, you could actually pretty effectively recreate the data set to an extent.
Yeah, you could. You could. And two, there are cases where, think educationally. If I'm looking at a distribution of test scores, let's say I got a mean score of 65 on a test, out of the 11 in the class here. Let's say we got a mean of 65. Does that mean everyone did terrible? No. Especially when there's only 11 people. We could have had one person who was up all night, didn't study at all, came in, hardly did anything, and got a 10 on the test. But then we had 4 A's and 5 B's and then a C or a D or something. One extreme score like that could skew the data quite a bit. And what that could do too, or the reason why it can skew it so much is because think about it. Your A range is a 10% range, and B is a 10%, C is a 10%, D is a 10%, and then your F range is a 50% range. Half the possible scores out there are all in one class. Okay? So, in order to analyze our data in that case, looking at the median score might be a better option. We have 11 people. What was the sixth highest score? And maybe that was an 83 or something like that. That's pretty good. Okay. I had an Algebra 2 class last year that it was very challenging to teach. My test grades regularly on the A to F range regularly looked like this. That was my grade distribution on most of my tests. Because I had some very gifted students. Out of the 13 in the class, I had probably 4 or 5 who always got A's and a couple others who sometimes got A's, sometimes got B's. Then I had 3 or 4 who, there were 2 that pretty much always got F's. And then, because one had, some of it was effort, but like one seriously had autism, one had some other learning disabilities. I had the whole gambit in one class. So, here's 2 people, 3, maybe one of them got a D. And then I'd maybe have 1 C and 2 B's or something like that. Is a mean score going to tell me anything? No. Okay. Hey, we're doing great. We averaged 70% on the test. Well, that doesn't tell me anything. I don't know what happened there, but that doesn't tell me anything. There, the modal score might be helpful. Hey, I had 6 A's. That's pretty good. We'll work on these guys, but we had 6 A's. That's really good. Or the median, especially because out of 13 people, there's usually 4 down here, and the rest were somewhere up here, so the median might have been a B minus. That's okay. You know, out of 13, what's my 7th score? If that was a B or a B minus, they're doing okay. Alright? So, it's helpful to look at these other values when we're talking about income. Okay? Think about if we did a mean income. Mean income, there's only so low your income can go, right? But obviously you might have one person who's making $5 million a year, and you could have 50 people making $10,000 a year, and you're still going to get an average, that's, somewhere around $1 million or whatever. So it's really easy. That's a case too where you'll look, and actually if you see a lot of data and statistics that like the government puts out or whatever, they're talking about median things. Same thing with home values. The median home value is this much because there's only so cheap you can build a house for, even if it's the dumpiest house in the dumpiest neighborhood. Okay, it's still going to cost a certain amount. But you can always make a house more expensive, right? So that's why they do a median rather than a mean value for homes. So, anyways, just trying to get you to think about the data a little bit here. And then finally, one other thing, to help us organize our data a little bit better, you actually saw this on one of the homework problems here where you were creating a frequency table. Okay? Well, how does that apply to, for example, our mean formula? Okay? We have these data values and then they occur a certain number of times. Alright? The value 5 occurred 3 times and 8 showed up 8 times and so forth. Okay? Well, when you're finding the mean, okay, notice how the formula changes a little bit. You're still doing the same thing in the end, but rather than hitting 3 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6 and so on, hey, there's 3 5s, so that's 15. There's 7 6s, so that's 42. And you see how we're multiplying each data value by its frequency, okay? And we're adding that up. So you'll see here, X is the data value, F is the frequency. We're adding those up after we multiply them, okay? The danger here when we're finding the mean is making sure that you divide by the proper value. Okay? You divide by the proper value. What can you anticipate would be the temptation here on this problem when you're finding the mean?
Divide by 7.
Yeah, to divide by 7. And people do that all the time. It's an easy mistake to make. You're like, oh, there's 7 things, so I divide by 7, and I get 39 and 5/7. That's my mean. Okay? No. How many actual data values are there? And that's where you have to add the frequencies. 40. So you'll see here, here's the sum of the data values times their frequencies divided by the sum of the frequencies, which is n. Okay? Now, finding the median and mode. I'll get this out of the way there. We found the mean. The median and mode are actually pretty easy to find as well, okay? The mode is really the easiest. What's the mode for this data? It's 7, all right? You look for the biggest number here, 7's the mode. Just be careful you don't accidentally say it's 15, okay? 15 isn't a score, that's a frequency, all right? That's another common mistake students will make. Oh, 15 is a 7, so 15 is our mode. No, 15 isn't even a score. 7 would be our mode. The median, you have to do a little bit of thinking here, okay? If I know there's a total of 40 scores, how am I going to find the median? It's that middle one, right? So where would that be if I have 40 scores?
Is it the average of the 19th and the 20th term?
Close, the 20th and the
21st. I didn't know what
21st.
to do.
Yeah. Okay. The median is going to be the mean of the 20th and the 21st. Okay. So here's where what you can do is you can make another column if you want and call that your cumulative frequency. And you'll even see this in some tables of data. Cumulative frequency. And this is helpful not just for the median, but we'll talk about this in a sec. How many scores are 3 or lower? Well, just 1. How many scores are 4 or lower? 2. Okay? Now we're at 5, I'm up to 5 scores. Once I get to 6, I'm at 12, and then 27, and then 35, and then 40, okay? Now this does, as I started saying it, it does tell you how many are that score or below, which could be helpful, you know. If this were a quiz at a 9, you know, how many people, you know, got a D or lower? Well, a D would be, you know, in the 60s. That'd be a 6 out of 9. So that means 12 people got a D or lower. Maybe we need to review what was on that quiz a little more closely. Okay? Or, you know, how many achieved a certain level or whatever the situation is. Okay? But here we can also see, all right, there were 15 sevens, which means both the 20th and the 21st are in that 7 range, right? So, not that you need to write this down, but the average of 7 and 7 will just be 7. Okay, so sometimes it does end up in the middle of one of these groups and then it's just 7. Sometimes you actually have to find the mean of 2 different scores to get it, but that would be our median. Okay, so that's our median. 7 was also our mode. Okay, if we were finding the mean, it doesn't tell us if this is a sample or a sample or a population, so we'll assume that it's just a sample. Okay, we have 278 over 40. Okay, so that's going to be 6 and 38/40ths, so 19/20ths would be 0.95.
Mr. Nixon, use the restroom, please.
Okay.
Can you explain one more time how we found median?
We found median.
Yeah.
Okay, we want the 20th and the 21st score. Okay, so here's number 1, 2, the last 5 is the 5th score. the last 6 is the 12th score. Now we're into the 7s, and the 13th through the 27th score are all 7s. So the 20th and 21st are both 7s. Okay. Alright, so how would you describe the distribution of the data here? Is it skewed one way or the other, or is it pretty symmetrical?
It's fairly symmetrical.
Yeah, it's fairly symmetrical. Our mean is very close to both the mode and the median. So we would say that this is pretty symmetrical. Okay? Anyone have any questions about any of this? Now, there's a variety of applications. For example, if you're given most of the data and you're given a median, you could use that to find one missing score, or some possibilities at least for a missing score. If you are given, the mode, well, not necessarily the mode, but if you're given a mean and you know all but one of the scores, you could find that missing score using some algebra along with your formula. Okay? So there's a variety of applications, and I gave you some to practice, and actually we're going to just use the last 10 minutes here. We can go ahead and start practicing with some of these. But, for example, here we have basketball teams playing in 5 different matches, okay, total, and we're analyzing what happens to some of those things. Here, understanding notation and applying it when we know the mean and we know how many scores we have, we can figure out, what's the sum of the scores. Again, we know the mean and we know all but one score. What's that missing score? Okay? Here, there's a number of scores we're missing, but we at least know they're all the same score. We could find those. 14, you'll need to think about a little bit. If 10 measurements has a mean of 15.7, 20 measurements has a mean of 14.3, how would we get the mean of all 30? Okay, kind of thinking your way through that little bit of problem solving there. And then here, if we know both the mean and the median, and there's 2 missing measurements, we can actually figure out what those are by comparing, alright, how do we find a median, how do we find a mean, what would those 2 different measurements have to be, okay? And then this, that's not the symbol for pounds, is it? Or
Is it euros?
Is that euros? Okay. So we have euros, and we're looking at people's salaries, okay? And then there's also there's a little analysis question that's kind of interesting to think about. And you could kind of think about it kind of in the opposite way. Once you calculate the median, mode, and mean, think about it the opposite way. What would the employees want to use to try to prove that they should get a pay raise? Because this is what people do. They take the same data and they look at different measurements for that data and they try to use that for what they want. It's done all the time. It's not necessarily right,
Nor
but
is it necessarily wrong.
it's not necessarily wrong as long as you're not trying to be just blatantly misleading. What you should be doing is using all the data and say, analyze all of it, and come to a conclusion that way. But think about that question, part B there, in both directions. Which one would the management want to use to try to keep salaries down? Which ones would the employees want to use to try to get salaries higher? That'll be an interesting question. So I'll let you guys start working on some of those. Notice that last one is on a different page than the rest. And I don't know if you guys looked at Skyward at the beginning of the week. I did actually modify what was originally in Skyward. I had a couple extra ones at the beginning that I eliminated, and I added number 11 here. So that was different. It's changed if you go back to Skyward now, it's changed. And I'll put this on the website as well. So, all right, we'll let you guys